Alright, so on this lesson we're going to be talking about triangle inequality theorem. We're not going to be getting into the proof at all about it, but we're just going to be applying the theorem to a series of problems. Now, on this first example, we're going to determine the two largest angles in the triangle. What you're going to want to avoid is just looking at the angles and trying to guess at which two are the largest. What you should be doing is looking at the side lengths, because here's how the triangle inequality theorem works. The longest side is always across from the biggest angle. So I know that since 5.8 feet is my longest side, that's across from my largest angle. I know angle A is the largest angle. I'm just going to make a quick note on the triangle, moving right along. I'm going to say, all right, next up is 5.6 feet. That's the next biggest side. So this is my middle angle as far as size goes, and 5 feet being my shortest side on segment AB, that's across from angle C, which would be my smallest. Since we're determining the two largest angles in the triangle, I know that that's angle A and angle B. Angle C is the smallest angle in the triangle since it was across from the shortest side, and that's how triangles work. All right, so on example 2, we're going to look at a different concept here. The basic idea is that any triangle you've ever dealt with ever has had to follow this simple rule, that if you add any of the two sides, they have to be greater than, not equal to, not less than, they have to be greater than the third side. So if I had 3 plus 4, that would be 7, which is greater than 5. 5 plus 4 is 9, which is greater than 3. 5 plus 3 is 8, which is greater than 4. So now we're going to test that out and see if these given measures could actually be that of a triangle. So 10 meters, 12 meters, 18 meters. The easiest thing to do, take the shortest two sides, always the shortest two, add them together, see what you get. Equals 22 meters here. Now, compare that to the longest side. Since 22 meters is greater than the longest side, 18 meters, this would in fact be a triangle. So my answer is yes, and this would be a pretty good explanation. The sum of the two shorter sides is greater than the third side. Now I'm going to look at part B. 2.8 and 5.7 are my two shorter sides, so when I add them together, 2.8 plus 5.7 ends up being 8.5 centimeters, and I'm going to compare that to the 8.7 centimeters, which is actually going to mean that 8.5 centimeters is less than 8.7 centimeters. Now, since the sum was not greater than the longest side, this is a no that these cannot be a triangle. Basically, on part A, they would be able to connect, but on part B, you would have your longest side, and the two shorter sides just would never be able to meet no matter what angle you tried to use. Because of this disconnect here, it's not going to be a triangle, while this one could have been. All right, going to go ahead and look at this last one because something interesting happens. So if you add your shorter two sides, the 5 feet plus the 7 feet, you're going to get 12 feet, which of all things is actually equal to the longest side of the triangle. Now the answer here is still a no. All right, the reason why that is a no is because if you had your longest side and you laid your two shorter sides on top of it, they would meet, but it would be on the line and it wouldn't be making a triangle. All right, next concept. We're going to actually be needing to find the measure of angle x first on this problem before we list the sides from shortest to longest. First thing we do, let's go and make the equation measure of angle x plus the measure of angle y, which is 48, plus the measure of angle z, which is 57, does need to equal 180. Now what I'll do is combine the 48 and 57, so the measure of angle x plus 48 plus 57 ends up being 105, and subtract the 105 from both sides. So the measure of angle x equals 75 degrees. I'm going to go ahead and pencil that in over here. Next up, we're going to list the sides from shortest to longest. The thing you don't want to do is just go off of how they look, because it can always be not drawn to scale. What I'm going to do is go ahead and start with the shortest side, which needs to be across from the smallest angle. Since angle Y is the smallest angle, that means that segment XZ is my shortest side, since it is across from it, going back to that triangle inequality theorem. So I'm going to start with segment XZ as my shortest side. It is going to be less than, go to my next biggest, angle Z, 57 degrees. Since that's my middle angle, this is going to be my middle length side, XY. Now my longest segment is going to be across from my largest angle. So just go to the 75 degrees, the largest angle, across from it, segment YZ will be my largest angle. So this is my shortest, which is less than this one, which is less than my largest. This problem is very similar to the recent one, because we're now just going to do the same with the angles. We're going from largest angle to smallest angle. So to start with the largest angle, I'm actually going to go to my longest side. NB is my longest side at 5.4 inches. So across from it is my largest angle. So angle M is my largest angle, which is greater than. Now, next up, 5.3 is my middle length segment. Across from it will be my middle sized angle. So angle B is the next largest angle in the triangle. Now for my smallest angle, it's going to be across from my shortest side. Since 5.2 inches is my shortest side, this angle N is my smallest angle. So angle B is greater than angle N. Largest, which is greater than my middle, which is greater than my smallest, angle N. All right, this last example relates back to example 2, the set of 3 problems that we did, where we added the sides to see if it was greater than the longest side. Now, the lengths of 2 sides of a triangle are 8 feet and 14 feet. Determine the lengths possible for the third side. Well, it's actually a range of things. To know what it is, basically we need to add and subtract these two numbers. So if I do 8 plus 14 and 8 minus, or 14 minus 8, excuse me, I'll actually get 2 different values here, which would actually be the endpoints of the possible range. So 14 minus 8 is going to give me 6 feet. It's not able to be 6 feet, but that's the lowest boundary for it. 8 plus 14 is 22 feet. So what happens? The lengths possible for the third side, if the third side is x units long, I'll write that down really quick since I'm introducing a variable. So 6 would be shorter than what it's able to be. So 6 is less than x, and 22 is actually longer than it's able to be. So x is less than 22. Notice I did not say equal to. So the reason why it's these values is x could, for instance, be 7, because 8 feet plus 7 feet would be 15 feet, which would be greater than 14 feet. X could, for instance, be 21 feet, because 8 plus 14 would be 22, which is greater than 21. And it could be any value between 6 feet and 22 feet. As a quick note here, I probably should have included the units when I wrote this inequality statement. So 6 feet is less than our third side, which is less than 22 feet. That would be the best way to present your answer here. So again, just add and subtract the 2 lengths that they're giving you to find the low value and the high value. All right, that's a wrap for this lesson. Please let me know if you have any questions or comments. Thank you.